Hi, my name is Anubruto Das. I'm a PhD student at the University of Texas at Austin in the School of Information. I work with Dr. Matthew Lees, and the works that I'll be presenting is done in collaboration with Dr. Matthew Lees and a lot of undergraduate and PhD students. The slides for this talk is available on my website. I think everyone in this forum are familiar with the need for professional fact-checking to fight with misinformation as a problem. And over the years, we have seen growth of these fact-checking organizations such as factcheck.org, Snopes, or PolitiFact, and several smaller organizations as well. But despite this growth, the sheer scale of the misinformation spread online is not matched with the manual expert effort associated with it. So the question is that whereas we are getting high quality fact checking from these professional fact checkers, how can we scale up? To address the problem, we see a surge of research in automated fact checking as well. One example being Fever 2.0. It's a workshop running for about 4 years now on developing automated fact checking. And there are several other research that's ongoing in this domain. We see that automated fact checking as a scalable way to address this problem. However, these models often perform poorly. So we are not able to maintain the high quality that we get from professional fact checking through these automated solutions. In this context, we look at explainable fact checking as a way to assist human fact checkers and improve their workflow through explainability and relatively less poor performing models as well. So what are the goals of these explainable fact checking systems? Just providing fact versus fake labels is not enough, because various studies have shown that without a proper justification, just labeling something as fake is not as effective. The second component is that users may not trust opaque classifiers. Even experts who are using these classifiers may not have the trust in the system if they don't understand how this works. As I already mentioned, that the AI solutions may not work as effectively in the context of fact checking, and they are prone to making errors. So how can we design intentionally for this AI fallibility and capture that in the workflow? Moreover, when it comes to fact checking, there is bias that comes from the user as well as bias comes from the tools associated with it. And how can we capture this interplay of different biases when users are consuming information? And finally, how can we combine humans' ability with AI speed and scale to provide a human-AI partnership to address the problem of automated fact checking? So today I will demonstrate this tool called ExFacto, which is a claim checker. It has a search capacity where one can go and put a claim that needs to be searched. And then there is a search engine API at the back end. Right now we're using Bing, where we go and filter out certain evidence that's related to this particular claim. And we kind of further filter it down to a set of sources that we already know. We have two underlying models, a predicted reputation and a stance model. So the predicted reputation assigns us a certain reputation score to the sources of these evidences. And the stance detector identifies whether a particular claim denies or supports or neutral to a particular claim. And as you can see, this little bot over here, which means this is an automated system, we can change that to be crowdsourced data as well. And based on this predicted reputation and stance outcome, the model calculates predicted correctness, whether a claim is true or false. So let's take a look at the live version of this tool. The claim I'm searching is Tiger Woods is serving suspension from the PGA Tour after failing a drug test. So when I hit check claim, it goes and brings out these evidences. Let me zoom in a little bit. Maybe it's a little hard to read in this font. Okay, so then we have three sources: the Gateway Pundit, USA Today, and Washington Post. USA Today and Washington Post with having slightly higher reputation. The Gateway Pundit is kind of in the middle, so that means our model is not totally sure how the reputation is. And we have three articles, and the model provides deny for the first one and neutral for the second two cases. As you can see, that stance detection is a hard task, and model has made a mistake because Tiger Woods' agent shoots down the report of failed drug test, which is basically denying the claim and not actually neutral to the claim. So what we provide users is a control through the sliders to override the model outcomes. So I'm going to change that from neutral to deny, which is true for the second case as well. And actually, this is just shock claim, which is a neutral. So in that case, we see that the predicted correctness is false. So we can say that, okay, Tiger Woods did not serve suspension after failing drug test. It's indeed a false claim. Moreover, if you have different trust in different sources, you can say that, okay, Washington Post is really more reputable. I'm going to put more reputation to it because I don't really believe the model. On the other hand, there is the switch between bot and crowd. If I change this, you'll see the crowd label data is available here, which is much more accurate because it's deny, it's slightly deny, and it's neutral. So there is a scope of integrating with the crowdsourcing in the backend. Another thing is the way this predicted reputation is correct is done is through keeping track of how many times a particular source gets a particular claim right. What I mean by this is when I click on this Washington Post, we have a collection of all the claims in our data set and what stance Washington Post had and what is the veracity of claim. And based on that, every time, let's say it's a false claim and Washington Post was against the claim, in that case, it gets a better reputation score. And that's how we kind of aggregate the reputation score over time. Obviously, there is another scope of just clicking here and going to read the article if a user wants to do that. So this is the overall capability. And the idea here is to provide user a dashboard to interact with the AI directly, as well as make their own decision and input their own knowledge in cases the AI is wrong. Let's read this comment strip quickly. When we have fake news that we're trying to verify, we go to Google and literally see the first link that agrees with me. That's called the filter bubble effect, and that's basically kind of shapes our opinion about things. So we see that there is fact checking and there is user bias, and we need to find a way to somehow communicate this user bias in the fact checking prototype. This is especially important when we provide people with the capability to alter model scores such as source reputation, which can polarize the user in their own direction and thinking, okay, if I'm left leaning, then I'll only score high reputation to the sources that are left leaning. So what we do here, we introduce a political leaning as a function of the adjusted reputations score on the news sources. So we have sources and we have their stance. And then this particular case, this is an imaginary example. So we have source biases from liberal to conservative, another form of a slider. And a user can alter the source reputation. And changing the reputation scores actually changes the predicted correctness, which we have seen already. It also shows the overall political leaning, as in it captures the state of the system as starting from a neutral position. As we modify this source reputation score, it can say that, okay, you're looking at this from a conservative perspective or from a liberal perspective. Similarly, a user can alter the overall political leaning. So imagine that in the comfort of your own house, you want to see how the world looks like from an extreme right point of view or an extreme left point of view. And then that actually distributes the score back into the sources. So kind of shows that if you're looking at this from a particular angle, these are the kind of reputation that people might be believing in for this kind of sources. So we have published a few results on these. The citations are available here. And again, the slides of this website, slides are available on my website, and the demo link also available on the slides. Thank you. I'll take questions.